Welcome to EDU World Space.
When we can't use regular tests, parametric tests, because their assumptions don't work, non-parametric tests are good alternatives. First, both groups have significant outliers. If we have that case, outliers are like weird numbers in data that don't fit with the rest. They can make results less reliable in regular tests, but a non-parametric test called the Mann-Whitney U-test or the Wilcoxon-Rank sum test could help. This test compares two groups by looking at the ranks which is the order of all values instead of the values themselves. Which makes outliers less of an issue. For number two, when one group has a skewed distribution and the other is symmetric, that would be like when one group has data that's lopsided. Okay, that could be an example of a distribution that's lopsided. And the other is more balanced, symmetric, normal. The Mann-Whitney U-test. Is again a good choice. This test is flexible with different shapes of data. And doesn't rely on the data looking normal to make a good comparison. Number three, both groups have a symmetric distribution. If both groups are symmetric, but we still can't use parametric tests, we can use the Wilcoxon-Rank sum test. If the data isn't paired. Or the Wilcoxon signed ring test. If data is paired. Paired like before and after scores. Since symmetric data is already more balanced, these tests can handle it well while still being non-parametric. And if there's no clear indication of what test to use, so when it's not obvious which test to pick, a safe choice is the Kolmogorov-Smirnov or KS test. This test checks if two groups are different by looking at their overall shapes without needing assumptions about what the data looks like. It's a good catch-all when we're not sure what to expect.